Let's look at solving exponential equations. These are just two very simple ones, but I want us to learn how to do this using the properties of logs we've already learned. Looking at this first example, we have 3 to the x equals 18. The first way we're going to solve this is by using logs. So we're going to use the operation of logarithms and take the log of both sides. So this would be log of 3 to the x equals log of 18. Okay, we have 3 to the x equals 18. So we're going to use the properties of logarithms and first take the log of both sides. So we're going to have log of 3 to the x equals log of 18. Now remember, our properties of logs tells us that if we have a power, like an exponent, we can bring that to the front. So we're going to take this x right here and bring it to the front to make it log x times log base 10. This is understood. We're just doing common log here of 3 equals log of 18. Now, the log of any number is just another number. So I want you to think about this expression as kind of being like 2x. And if I have 2x equals something and I want to solve for x, I divide by 2, right? That's what we're doing here. It's just that this 2 is more complicated and it's log of 3. But we can still divide that out. So we want to keep the x where it is and divide by log of 3. And we're going to do that on the other side as well. Divide by log of 3. That's going to cancel here, and this is going to give me this expression that I'm going to put in the calculator to determine an answer. And this says round to 3 decimals, so that's what we're going to do. So we've got log of 18 divided by log of 3. This gives me 2.6, it's actually 2.6309. If I'm rounding to 3 decimals, 1, 2, 3, the fourth needs to round that up. So this would be 2.631. Okay, now that is one way to work it. I want to show you another way. Another way is to take this 3 to the x equals 18, and I want you to convert it from exponential to log. So like when we were solving log problems, we converted from log to exponential. Let's do the reverse here. So we are going to have log base 3 of 18 equals x. Remember, backwards C is how I've taught this. Now, how do I figure out this part right here? We've done this. You just got to remember what am I going to do here? This is change of base. So we're going to do change of base by doing straight across log of 18 divided by going down log of 3 equals x. And now we have the exact same expression as we did over here, and it's going to give us the same answer. So it doesn't really matter which version you use. I don't really care. Pick one that you can remember. But again, if you do this one, you've got to remember to do change of base. That's going to be the key there. All right, let's look at this other example. We have e to the x equals 14. Now, on the first example, I used the operation of taking the log of both sides. But here, I've got a base of e. So instead of taking the log of both sides, I'm going to take the natural log of both sides. So we're going to do natural log of e to the x equals natural log of 14. We can put these in parentheses if we want to. Now, what is the natural log of e to the x? Do y'all remember? Natural log e to the x. Natural log is log base e of e to the x. And if our bases are the same, the answer is just the exponent. So this expression is just x equals natural log of 14. And now, literally, all you do is put that in the calculator. So natural log of 14 in the calculator is 2.6390. And I need 3 decimals, 1, 2, 3. That's not going to round it up. So 2.639 is our answer. Okay, so that is another way you can do this. One note on this, again, if you have an E in the problem, use natural log. If you don't have an E in the problem, use regular log or common log, okay? These are just two very basic exponential equations, but these can get far more difficult. So basically, this is just helping you solve the very basic ones in this exponential format.